doesn't really matter which calculus class or beyond you might be taking, but there are times when you just need to know about some details rather quickly. So this is a quick little crash course that's going to observe some fairly common functions from the days of before calculus, pre-calculus, and we're just going to quickly itemize the domains or the inputs and their ranges or the outputs. This is not reteaching or attempting to teach about these functions from scratch. You should already have some exposure to all of these functions, but for 3 of the items on this list, you might see some details mentioned that are unfamiliar to you. That shouldn't be a problem because the main point of this is domain and range of some fairly common functions. So let's look at the list I've created. We have the sometimes called the rational function 1 over x, the square root of x function, and the cube root of x function. We certainly could include other types of roots, but having what's called an even root and an odd root is sufficient for the main idea I want to bring up here. Here's a square root function that has sort of a unique twist. I'm guessing you would have seen this in a pre-calculus or before calculus type of algebraic course, but you may not recall it from memory. So give me a moment and I'll get to that function. We have the natural log of x function. And finally, 2 of the 6 possible common inverse trigonometric functions. You can use the formal arc sine of x or the informal sine inverse of x, similar here. There really are more than just 2 notations. Some calculus books only use one type of notation, some use more than one. And I can tell you in my own career, I've seen variations of these notations that we will not cover in any video that I would make in a class for today. Now, let's get down to it. With each of these functions, I have included a graph because the goal is, again, not to reteach, but just to put out some key facts. So, starting off the list, the rational function 1 over x. Here is its graph. For domain, I'm going to use in the English alphabet the capital letter D. And the domain of this graph is all real numbers, but we cannot divide by 0, so x is not 0. There are, 4 or 5 fairly common ways of writing this that are not just writing it out this way. There are a number of other set notations, interval notations. You can even use a number line. There's inequality statements and conjunction or disjunctions. There's so many ways of writing it. I'm just going to give it to you one way. It turns out for the range, the outputs of this function, I'm going to use the capital letter R. This fancier letter R is commonly used in the Western world for real numbers. The range is nearly identical to the domain. The y values can be positive, the y values can be negative, but the y values will never be 0. So I'm going to simplify this statement and just use this for the all reals, but the y value cannot be 0. So that is the 1 over x or rational function. The square root function. Its common domain is in the reals. X has to be 0 or greater than or equal to 0. You could certainly use interval notation, which would be writing it 0 to infinity. And again, there are 2 or 3 other fairly common notations for this. You and your instructor can talk about it, but for my class, these would be the 2 I would be expecting, generally speaking. And it turns out the y values for the range are any value 0 and above. It may not go up as quickly as it goes to the right, but the y values can be any real number greater than or equal to 0. So there's your domain and range of the square root function. Now, again, if you're studying these functions from scratch in an earlier algebra course, you'd spend a lot more time on this concept. I'm just sort of putting some key facts out into play again that you will need oftentimes in a variety of calculus situations. Next, the cube root function. The cube root function. This one's kind of fun. Its domain and range are the same description. You can use any input you want for the x, all reals. X can be a negative number. The cube root of -8 is -2. You don't have to worry about imaginary solutions in a real world graph. Certainly there are 3 cube roots of x, but this standard cube root symbol will give you, well, something that appears in this graph here. One of my favorite features about this graph in Calculus 1 is it has a tangent line everywhere, but its derivative is undefined at the origin. If you're taking Calc 1 and watching this, that will make sense soon enough. Now, here's one hopefully you've seen before, but it may never have played a prominent role in a course of yours before now. When I'm teaching calculus, it's a minor player in Calculus 1 and 2 or first and second semesters. It becomes a more significant contributor later in the 3rd semester course. If it looks like the graph's incomplete, no, it's not a parabola. It is a half circle or a semicircle, and it finds its origins, x squared plus y squared equals 1. If you solve for y, 1 minus x squared, the positive square root is this graph right here. Some instructors will intentionally put a plus sign here just to make sure you know it wasn't just an accidental thing, it's intentional. This is a function. For every input, there is one output. What you're seeing here is the top half of a circle. The top half of a circle. Its domain, these x values all vary from -1 to +1. -1 less than or equal to x, less than or equal to +1. But the y values are only the upper half of the circle, which would be from 0 to 1. And I'm just going to write the interval notation for this to keep it short and sweet. Moving along, another really important function, but because its history in your mind doesn't go back as far in mathematics, it may have trouble staying committed to memory, and that would be something related to logarithm function, which is the inverse of y equals e to the x. You should know that we could spend there could be a lot of videos on this topic alone. If this weren't for giving sort of a crash course for students sitting in a calculus class, there would be a lot more information here. This graph has 2 nice points on it. The natural log of 1 is equal to 0. And the other nice point here, where the output is 1, that's the natural log of e, about 2.718. But I'm getting a little distracted here. I should say focus on what I was going to show you. The domain, the inputs have to be positive. No 0, no negative. unless you want to play in the imaginary/complex world, which I'm not for the purpose of this video. So x values are positive, but the range goes down forever, goes up slowly, but forever. All reals, all reals. All right, we're closing in now. If you remember the first list I showed you, the inverses of sine and tangent were on the list, but I'm going to guess that you're not going to recognize maybe the graph I'm about to show you. If you do recognize this graph, then your teacher was having fun nerding out a little bit more than the textbook probably did. There we go. Arcsine or sine inverse. This particular graph right here, that you see is not this. This right here is only this part of the graph. That is the inverse of sine. That is the inverse of sine. This is a function. What you see here is not a function. That part there, my students and visitors, is the graph of x equals sine y. There are a number of free graphing softwares out there that will graph x equals sine y, but most graphing calculators do not. This is the graph of x equals sine y. This graph here that's highlighted, its domain are all values from -1 to +1 here in the graph, and the range from -π/2 to +π/2. This is a pretty easy graph to forget the details. It's pretty common to forget these little details. If you wanted to know about some angle that was not between -π/2 and π/2, if you're studying things on a circle, for example, the inverse sine function on a calculator can only give you this much. You would have to use other tools, knowledge, in order to find those alternate values. And last but not least, the inverse of tangent. Remember what you're seeing here, the complete graph is x, and scroll up a little bit here, x equals the tangent of y is the complete graph. But this part here is what is in blue. And the domain of this function is all real values. You can input any x you want to inverse tangent, and the output you get, called the range, will be something between -π/2 and +π/2, but not including. It will not include. It will get close to but not touch that horizontal line here and here. All right. As you're studying different types of functions in the sense of calculus, you may be called upon to know some of these key facts. So this video is designed to just give you the quick basics. Here's a quick picture. Here's what the inputs and outputs are allowed to be for these functions. It is not me reteaching any of these concepts. Just a quick little highlighting. Okay? Until next time.